Today's lesson we are going to handle solar inverters or inverters. Don't say that it is only solar inverters, but you can use inverters on various projects. Okay, now today we are going to look at the inverters. Inverters. Listen that word very well. Inverters. Inverters. What are inverters? Let's drive through our topic today. Today, we technicians will start about the inverters, and some people, our clients, they ask about what's the use of an inverter. Some technicians can size a solar system without an inverter, and some can size with an inverter. But a lot of our electronic gadgets uses inverters or uses AC power, alternative current power. Okay, and other gadgets may not use AC power. They use DC power, direct current. Now, if we are going to use an AC power, we are supposed to invent or to introduce an inverter. And where the inverter? The name inverter, it inverts or converts DC to AC power. Let's say we have our simple question here. What is an inverter? What is an inverter? Personally, I can say an inverter is electronic device which converts DC to AC power. It's an electronic device which converts DC to AC power. Which electronic device I mean? This word electronic device, inverter is like this. Let's say this is our inverter. Okay, it has sockets. These are sockets, the behind part, the output. Let's say this is output. It has the front part. The front part will have terminals, a positive terminal and a negative terminal. This is the input. The input. It will input the voltages which are DC voltages. These voltages will be in DC, or let us say 12 volts. 12 volts DC direct current from the battery. This power, let's say we have our battery here. Battery has a positive terminal and negative terminal. We connect our positive terminal here, our negative terminal here. This is the battery. Now, battery, this is our inverter. The battery will supply 12 volts to the inverter. An inverter, as we have said, is an electronic device which converts DC to AC power or electricity. Electronic, once you hear what electronics, I told you the time we're going to enter electronics, we shall see the electronics, what the word electronic means. The word electronics means the combination of electronic components to make a device. They combine the electronic components. Electronic components, I mean the resistors, the capacitors, the transistors, transformer, those are electronic components to make a device. That's why we have called it an inverter is an electronic component, meaning it is a combination of electronic components, the ICs, the integrated circuit, the transistors, the capacitors, the FETs. We shall learn about those things, which these electronic components are combined together to convert the DC, the 12 volts, which is the input. They convert that 12 volt DC into 12 volts AC. That is the inverter. And the way the inverter comes, you invert 12 volts DC to 12 volts AC. We shall convert this 12 volts DC to 12 volts AC inside here, inside an inverter. Okay, that's the way it does. The function of how it converts the 12 volts DC onto 12 volts. Now, this output, let us say, inside here, the inside the circuit, the electronic device which converts DC to AC electricity. Here we shall have, this is the output of an inverter. This is the input. Input is 12 volts. Output, inverter will produce 110 or 120 or 140 volts. It depends. Okay? Output may be 110 volts AC or 220 volts or 240 volts AC. This is now AC. An inverter has inverted or converted a power from the battery, which is DC, into AC. But it has again increased the voltages. Remember, we have said here an electronic device will convert the 12 volts, only the 12 volts which you have supplied it with, the input 12 volts. Then this electronic device, let us say this is our electronic device. We have our, let us say, resistor. Resistor is there, the input positive, negative. We combined with a capacitor, with a transistor, with again resistor. I'm giving you just a simple circuit diagram. Now this circuit diagram, we have capacitor, transistors, okay, transformer on the circuit. Now this circuit, no, transformer is outside the circuit. Now this electronic circuit, it converts 12 volts. We are feeding it with 12 volts DC. Now it converts, it has the output. Okay, it has the output. This output will be in AC. It has converted this DC, but the voltage remains 12. Here we shall get 12 volts. 12 volts from this circuit inside the inverter. Now this 12 volts will be in AC, alternative current. 12 volts AC. And this circuit is what we call electronic device. Some electronic devices are combined to convert DC to AC power. Now check another logic. This board, this electronic board is inside here, the inverter. It has produced 12 volts AC. Now, why then that an inverter output has 110 volts, has 220 volts, has 240 volts? Why? Because we have something inside here, inside an inverter, a transformer or a coil. Okay, there are types of transformer, toroidals, Now, it depends which transformer is inside the inverter. This transformers have types. We have step up transformer and a step down transformer. Now here we have 12 volts AC from the circuit. The circuit has done its work. 12 volts AC, and it is complete. It has done its work, a combination of electronic devices. Now it is combination of electronic device, and it comes to be an inverter, an electronic device which converts DC to AC. And we have our AC in 12 volts. Now here we want this voltage 12 volts to come out to be 110, 220, 240 volts. We shall introduce a transformer. Let's say this is AC, meaning live and neutral. The name has changed from positive to negative. Now we have live and neutral. That is alternative current. Now we are dealing with live and neutral, the power which shocks. Live and neutral, we want to 12 volts. We want to make it 110, 220, and 240 so that our machines can run. Which machines? Like, let us say washing machine will work on this AC 240 volts. Washing machines, our televisions, refrigerators, lights will work on AC, but it needs these gadgets needs high power, high electricity, high voltages of 110 or 220 or 240. This transformer, we shall apply here a transformer. Let us say this is the secondary. There is a coil. The secondary, this coil will be tapped. One terminal will be tapped on the live, and another terminal will be tapped on the neutral. And you know the principle of transformer. I know we shall go on transformer. Some may not be having knowledge about the transformers, but we are going to look at the transformers, the whole information about the transformers. Okay, how you can wind the transformer, how you can rewind the transformer, and how a transformer works. When we start our electrical principles or electrical works. Now this transformer has a primary side which is connected on 12 volts. This primary side, as I told you, it has two types. A transformer has two types, a step up and a step down. A step down transformer, you just hear the name, step down. If the voltages is let us say, if the voltage is, let us say 110 volts AC, you know, transformer works in the principle of magnetic fields or electromagnetic fields. You know, when power passes through this coil, we shall have electromagnetic fields. There is no connection with a primary. Secondary winding has no connection with primary winding, but the connection there is the electromagnetic fields, the fields around a cable. When power is passing through, there are some fields around it. Now these fields around it will penetrate into another coil, so that if I was explaining the step down types of transformer. We have step up and step down transformer. On step down transformer, it steps down the voltages. Meaning, if the voltage is 110 volts, if you use a step down transformer, if you want 12 volts, this transformer will step down the 110 into the 12 volts. Meaning, on the primary side here, this is the primary side. This is the primary, this side is secondary. The output is the secondary. Primary side, when it is stepped down, meaning primary has more windings. These are the windings. and secondary will have few windings, so that it produces little voltages. Like, let us say two windings only to make 12 volts AC. Transformer are good on ACs, not good on DC. DC is direct current. It doesn't produce that much or eddy currents around here. The fields we need, which can penetrate to another coil when it is in DC. But AC is good. It produces our electromagnetic fields. Here, this secondary coil will have few coils, and primary will have more coils. Coils are the windings you wind like this. And this is a step down. Step down will produce 110 to 12 volts AC. This is a step down. Now a step up. Step up will step up. Now this is the inverter. In an inverter we shall have a step up. Because we have 12 volts, we want it to step up the voltages high from the 12 volts. Meaning we shall have few windings on the primary coil and high or many windings on the secondary coil, so that these windings, the more one turn can make half a voltage or a quarter of a voltage. It depends on which type of a transformer you're using. These primary windings will be few on a step up. Then on the secondary, we shall have very many windings to make 110 or 220 or 240 volts AC from the transformer. We shall come at this topic about the transformer when we reach on the electricals, and you will master all transformers very well. Every transformer you will see, you will just look at it and you know on which terminal you are tapping on the 110, which terminal is bringing 220. Sometimes some transformers have 3 output like this. It has a tap in the middle. If this topic will be good when we enter transformers. Okay, when we enter electricals, I was giving you a bit of electrical about the transformer in an inverter to step up from 12 to 110 to 220 to 240 volts. And the circuit, the electronic circuit, because we have said an inverter is an electronic device which converts DC to AC electricity. DC, this is the DC from the battery, which is connected to the inverter, and an inverter has an electronic circuit. Which electronic circuit? I said electronic circuit is a combination of resistors, ICs, transistors, capacitors to produce AC, to convert. They have their functions. We shall see how they function to convert to convert DC into AC. Now from AC here, they convert the same voltages, which is the input, which was 12, and the output, it will be 12, but the name will change from DC and it will be AC. Okay. Now this AC 12 volts will be supplied to the transformer to step it up, and the transformer will produce 110 or 120 or 100 or 200. 110, 220 or 240 volts, which we use to run our refrigerators, the lights, the TVs, the washing machines. Okay, and this is the principle. I would love to go when we reach. Don't forget, when we reach, subscribe the channel, because you'll enjoy when we reach on the transformers. You'll see where do we get the neutral point, where the earth, where do get the earth from, or everything we come from the free phase system. We shall read there and we enjoy that topic. Now this inverter, it has outputs, and these outputs are, sometimes it has 1, 2, 3, 4, 5, 6, and they divide it. Okay, they can say this part on top, let me not confuse you with this. They can say this part on top, the output of an inverter, it is 110 volts AC. Don't forget to read these technical voltages as a technician, please. Because some gadgets, also some TVs, the TVs have transformers in it. Some, like flat screen, have no transformer. They use circuit to drive the TV instead of a transformer. Now, some electronic gadgets, they use 110. If you exceed 110, it will blow. So always use the technical information behind any electronic gadget. It has a technical information. Look at the voltages it uses, meaning look at the input voltages. When the input voltage is 110, you plug here your gadget, either a TV, either a laptop, either a fridge. Okay, the next sockets on the inverter, make sure you read. They might write this socket, these two, they produce 220 volts AC. These two produce 220 volts AC. Some manufacturers produce electronic gadgets which uses 220 volts, and once you put them on 110, they don't work. Once you put them on 220, they work properly. Okay, get to note that on any electronic gadget there is an input voltages. Now on the last one, they can put that it goes to 240 volts AC. You see? And all these terminals, all these voltages are tapped on the transformer. It has a transformer. Transformer is the one which is tapping which brings the output. Let me give you a simple diagram for that transformer. How it comes to be 110 in this socket, this again another socket, 220, again another socket, 240. Okay, a transformer is like this. Primary, which is tapped on the circuit, which is inside. This circuit diagram has 12 volts. This is live, this is neutral. You have the coil. Now on the secondary coil, we have this first terminal tube. Again, we don't cut the terminal. We again bring this terminal. Again, we do the winding. Meaning, we have divided the voltages. So we shall do the mathematics around the transformer when we reach on the transformer. Then this terminal will be connecting to 110 volts. This second one, 220. The third one, 240. And the neutral, you remember we have our neutral here. You see how these voltages are? Now they tap them, neutral, live, neutral. This is the live part, live. These are live. And our inverter is completely ready to supply us with power to our gadgets. And this is how we can drive, how we can use our inverter. Always read the important specification behind an inverter. Never just connect an inverter and without reading, which it has. Inverters are calculated in wattage. And remember, we saw that you can't use an inverter without knowing the loads of your client. You need to first calculate the loads, then you can come on and see which inverter is good for you. Okay, we're going to discuss everything. How do you specify the inverter? How do you choose the inverter for your client, or the best inverter you can use when you're dealing with the wattage. And this is the principle of the inverter. From the battery DC to the inverter, the input is 12, but the output is 120. But in the inverter there is a circuit board which converts DC into AC, and the AC which is outside, still has small voltages which need to be stepped up. Step up, we shall introduce, there is a transformer inside there. We shall see the transformer, and we have a different output, the voltages output. And that's how the inverter converts our DC power, which is kept in the battery, in the chemical energy. Okay? And we have our AC for our houses. And this battery, it gets its power to charge from the solar panel. And the solar panel, with the help of a regulator, to charge it fully or control its lifespan with the help of a regulator. So now we shall see this inverter. It has some types. Okay? Inverter has types. We need to see which type is good and which type is basic for which specifications. Which type can we use for our household? Which type do we use for industry? Which type do we use? We shall see which type of inverter we need to install for our customers, or which type of inverter we need to install when you're dealing with a solar plant. Okay? Next topic, we shall see the types of inverters. Types of inverters. We see which type of inverter do I need to get, because you can't go just on the market and get an inverter. You need to know which type you need, because you might buy an inverter which is not suitable for your system and is suitable for a solar plant. But you have the money and you can go for anything and you buy an inverter which will not work for you properly. Okay? And after that, we shall see even some inverters have input MPPT or PWM charge controllers, and it is built what we call 2-in-1. It is an inverter, still it has a regulator inside it to regulate the charging of the battery. And we shall see on the sizing. Okay, don't forget to subscribe. We shall see notes about the sizing of the inverter, because we can't come on and we leave the topic without telling you how you can size. You know, a lot of technicians get this job and they start sizing inverters. You become this inverter sizer as a technician. You can specialize yourself. That for me, my job is to size the inverters, and people will reach at you that, where are you? Dennis, where are you? Size for me my system. I have the loads like this. Even some technicians don't know which inverter you need to use. You have the customer, but you want to give the customer the right specified inverter. Call someone who is best on calculating or sizing the inverters to solve the problems, because you may buy an inverter for one day, it blows and it's expensive, because inverter, once you undersize it or you oversize it, you are making mistakes. You shall do the calculation and see, because I want you to be the one who can size everything. You know, you have sized the solar panel. We know how to size a solar charge controller. We know how to size a battery. Why don't you learn how to size an inverter? Next topic, we are going to see the types of inverters. Then we shall see the waveforms. You know, this inverter they produce waveforms, the outputs. The waveform, I mean, waveform may be sine wave, or modified waves. We shall see how it is. But I love you to know how to size an inverter, because this channel is a technical channel. I don't want you to be only in theory. I want you have the technical with you. Someone will just call you that I have my load, I have 1,000 loads, meaning I have TVs, lights. Be able to size for that friend of yours or a customer. the proper sizing of an inverter. Thank you for watching. See you in the next video about the types of inverters you will need to use in your system. See you. Thank you.